Welcome back. Now, the Aura damage gameplay ability has lots of parameters. Well, not a lot, but a few, and some of them have to do with debuffs now. Now, I'd like a nice, easy-to-use function on our ability system library that can take in a number of parameters, including a damage effect, and just apply that damage effect to some target. So all the things associated with that, setting all the set by color magnitudes, I'd like to be handled by this function. Now, this function can take a whole bunch of parameters in, but we're going to have more and more parameters as we create more and more combat tricks and combat features. And each time we add more parameters, we're going to have to add those parameters to this function we're going to make. So to get around that, I'd like to make a new type of struct for damage parameters. And the struct can take all these parameters and store them, and we can simply pass that into our function that will apply the damage gameplay effect. So we're going to create a new type, and I'm going to put this in the header file where we're defining our ability system types. So that's going to be Aura ability types. And here in Aura ability types, this is where we've defined our custom gameplay effect context. This is also where I'd like to define my custom struct for damage effect parameters. So we can put this above our effect context or below it. It doesn't matter. I'll put it above. And this is going to be a struct. I'm going to call it F damage effect params. And I'm going to make this a use struct with blueprint type. So it gets a generated body. And F damage effect params can get a default constructor. I'm just going to define it, open and close its body here like that. And because I plan on passing this struct over to Aura ability system library, I'm just going to have a world context object in here as one of the member variables of this struct. It's going to be a UObject pointer. This can be actually a TObject pointer of type UObject. And I'm going to call it world context object. And I'll set it equal to a null pointer. Now, this will be a U property, but I'm not going to expose any of these parameters. So if we feel like exposing these to Blueprint, we can. I know it's a Blueprint type. That doesn't mean we need to set these necessarily in Blueprint. I plan on setting them from C++. Now, we'll have a world context object. We're also going to have a damage gameplay effect class. This will be a T subclass of, and it'll be a U gameplay effect. And this will be the damage gameplay effect class. So we'll call it damage gameplay effect class. So giving this a U property as well. We can set this to a null pointer. We can initialize everything to null that we can. Now, the damage effect params is going to carry the source ability system component with it. So we'll make a TObject pointer of type U ability system component called source ability system component. And in addition to that, we'll have the target ability system component. Now, we won't be able to set this until we know what the target ability system component is, but as soon as we do know, we can set that. So I'm going to also have a target ability system component as well. And I'll just be giving all of these U property macros. Now, damage effect params needs to know how much damage to cause. So I'm going to have a float. We'll call it base damage. It'll be initialized to 0. We can also carry along the ability level. So I'm going to have a float ability level, and that'll be 1. So if we don't set it, it'll just be 1. We're going to have a damage type, so we know what kind of damage we're causing. So we'll have an F gameplay tag called damage type. And we'll set that equal to an empty F gameplay tag. And of course, we'll have 4 variables pertaining to debuffs. We'll have float debuff chance. And these will all get 0 by default. We'll have a float debuff damage. We'll have a float debuff duration. And we'll have a float debuff frequency. So if we have damage that doesn't do any debuff, we could just set that debuff chance to 0. So we'll go ahead and just stick a U property on everything here. And with that, we have the makings of our damage effect params. So because we have damage effect params, and we have an aura damage gameplay ability, these effect params are going to be set based on variables that exist in our gameplay ability, such as the base damage, once we retrieve it from a curve table perhaps, and the ability level, the damage type, and these variables here. So I think it would be nice if we created a function on the damage gameplay ability that can make damage effect params from the class defaults. So we'll make a function that can do that on aura damage gameplay ability. This can be a public function, and we could even expose it to Blueprint. So we can make a function that returns some F damage effect params, and we can add the include for that aura ability types here so that we can use this type. And the function will be make damage effect params from class defaults. And this can take in an A actor called target actor, passed in by pointer. That way, if we already know who the target is, then we can get its ability system component and set any parameters from that target actor. And if we don't know who the target actor is, we can pass in a null pointer. In fact, we can just set this equal to a null pointer by default, and that way it's an optional parameter. So we can generate this definition. And what this function will do is create a new F damage effect params. So we're going to say F damage effect params we'll call it params. And we can start setting things on the params. Now, first we have params.worldContextObject. I'll go in order of the order that I added these in aura ability type. So we'll start at the top, worldContextObject. So worldContextObject, and it's tempting to just pass in target actor, but target actor could be a null pointer. So we definitely want a valid world context object here. So I'm just going to pass in the avatar from this ability so we can get avatar actor from actor info and pass that in. Now the next thing we added was damage gameplay effect class. And on the aura damage gameplay ability, we're going to have a damage gameplay effect class. So we can set that right there. Now the next one in our damage effect params is the source ability system component. And we can get that from an ability, no problem. So we're going to take that source ability system component, and we can get our ability system component by using get ability system component from actor info. After that, we have the target ability system component, and for this, we may or may not have a valid target actor yet. So what we'll do is just place an if and say if target actor, then we'll call get ability system component on the U ability system blueprint library. So we'll say get ability system component passing in target actor. And we'll only call it if target actor is not a null pointer. Of course, get ability system component, if we go to it, we'll see that it calls ability system globals get ability system component from actor. And if we go to its definition, we see that if actor equals null pointer, return null pointer. So really this check is already done for us. We don't actually have to make that check. So if we want this to be a little bit more compact, it's no problem just setting that ability system component to what's returned from this function, as what's returned from this function will just be null if target actor is null. So we can say params.target ability system component equals, and we'll call that function. So I can close ability system blueprint library. After target ability system component is base damage. Now base damage is just a float in our params, which means we need to perform that lookup from the damage curve table, right? Well, we can do that pretty easily. So we're going to say params.damage, and it's actually base damage, and that's going to be gotten from our damage. And from damage, we can call get value at level, simply passing in get ability level. Now, after base damage is ability level, so we can pass that in as well. So we can say params.level, or ability level, of course, equals get ability level. After ability level comes the damage type, so we can say params.damage type equals damage type. And after the damage type, we have debuff chance, damage, duration, and frequency. We're going to set those as well. So params.debuff, I'm going to go ahead and copy this. And we have debuff chance. We'll set that equal to debuff chance. We have debuff damage. That'll be debuff damage. Debuff duration equals debuff duration. And debuff frequency will be debuff frequency. And after that, we've set all the parameters, so this function has done its job, and it can simply return params. Now, I see this squiggly here. You probably noticed this. I completely breezed over it, but I didn't actually set damage gameplay effect class equal to damage effect class. That's something that I needed to do. Now the function is complete. And actually, this can be made const. It isn't changing any state on the ability, so we can just stick the const keyword on there, no problem. And now we have make damage effect params from class defaults. And this makes it easy, so we don't have to just create an F damage effect params and manually fill everything in. It's just going to do it itself. It's an inherent ability. That's not to say we couldn't create an F damage effect params anyway. But now we have this, and now we can create a function on our ability system blueprint library that takes one of these effect params and applies a gameplay effect. So that is our next task. And now we can create a static function on our ability system library that will take in an F damage effect params, and using those params, it will apply the damage gameplay effect to the target. And that's going to be your quest. So we'd like a function to apply a damage gameplay effect. So create a function in Aura ability system library for doing this. Make it take in an F damage effect params, and it's going to assign all the set by color magnitudes for the gameplay effect and apply it to the target. This can be a static function, and you can expose it to Blueprint if you like. So pause the video and create this function in your function library now. Okay, so we need a function that can take in an F damage effect params. So I'm going to close all tabs except this one, but I'm going to open up my ability system blueprint library. That's going to be in ability system. And here it is, Aura ability system library. I'm going to make a new function in here. And I'll go ahead and stick it second to last, because this weird little function off on its own doesn't have a ufunction macro. So I'm going to push it off to the side, and we're going to make a new static function. And this is going to be apply damage effect. And it's going to take in a const reference of F damage effect params, and I'll call this damage effect params like so. Now, I didn't give it a return type, but that's something that you probably found yourself wondering. What is the return type? What should it be? Should it be void? Well, when I apply a damage gameplay effect, what I'm left with is an effect context handle. Sometimes you may wish to keep that context handle and hold on to it, hold it dear to your heart. So that's what I'm going to return, is an F gameplay effect context handle. It's okay if you didn't do that. That's just what I'm going to do. Now, I'm going to go ahead and generate the definition, but actually, before going in and adding things to it, let's make it a U function. I'm going to go ahead and make it blueprint callable. So I'm going to copy the U function macro from up here and stick it right here. And subcategory can be damage effect. Okay, so what is this function going to do? Well, first, I know that I'm going to want to apply a gameplay effect. We can work backwards if we like. I can call apply gameplay effect, one of the various versions of it. And if we're going to apply a gameplay effect, by this point in time, we need the target ability system component to be valid. So if it's not valid by this point, I'm considering that an error, and I'll go ahead and let it crash. So to apply a gameplay effect to the target, I need to get that target, so I'm going to get it from damage effect params, because we have a target ability system component, and the target ability system component has apply gameplay effect to self. We can apply a gameplay effect spec to self. You could have used apply gameplay effect spec to target, but then your source ability system component would have to be valid, unless you called apply spec to target from the target to the target. Either way, we have options. Now, if we call this function, we need a gameplay effect spec, right? Which means we need to make one of those. And I'm going to make one from the source ability system component. So I'm going to take damage effect params dot source ability system component and make a gameplay effect spec with make outgoing spec. Now, make outgoing spec is going to need to know the damage gameplay effect class, which also exists in the parameters. So we can take damage effect params dot damage gameplay effect class. It also needs the level. That's in our effect params too. It's the ability level. And finally, the context is the last input. We're going to make an effect context as well. So if we take our damage effect params, we take our source ability system component, we can call make effect context. You see how we put a few key pieces of information into this struct, and all of a sudden we already have the ability to do a lot of things? It's kind of amazing, right? Now, once we've created the context handle with make effect context, I'm going to store it in a local variable. So this is an F gameplay effect context handle. I'm going to call it effect context handle. And we know that the context handle has a source object we can set. So I'm going to take effect context handle dot source object. Actually, it's add source object. And I'm going to add the source avatar actor. So I'm going to go ahead and make a const local a actor for storing the avatar actor. I'm going to call this source avatar actor and just get it from the ability system component on the source. So that's going to be damage effect params dot source ability system component dot get avatar actor. So I have the source avatar actor, and I'm going to pass that in to add source object. So my effect context has the source object. Now make outgoing spec needs that effect context handle. So I'm going to pass in effect context handle. And this outgoing spec is an F gameplay effect spec handle. So I can save that in a local F gameplay effect spec handle called spec handle. Okay, so we now have the spec handle. And when we apply the gameplay effect, we can pass in the gameplay effect spec. Now, we can do what we've done before by taking a spec handle, accessing data, and dereferencing that pointer. We've seen before that we had to call get, right? But I'm going to let you in on a little secret. You don't actually have to call get. Dereferencing the wrapper will also give you the dereferenced value inside of it. Pretty cool, right? A little bit less syntax there. So now here's the thing. We have basically just created a convenience function that takes all these params and just applies the gameplay effect carried in those params. But we need to assign set by color magnitudes, don't we? That's the whole point of making this function for our convenience. So we're going to assign set by color magnitudes here. And we'll start with the damage. That's the most important. Now, to assign a set by color magnitude, we use the Ability System Blueprint library. And the function that we need is assign tag set by color magnitude. And it needs a spec handle. Well, we have the spec handle. We can pass that straight in. We also need the damage type, and that's on damage effect params. It's called damage type. We also need the magnitude, and that's the damage on damage effect params. It's called base damage. So now if we call this function, passing in some valid effect params, we'll basically just have a damage gameplay effect. Now I'd like to also assign tag set by color magnitudes for all the debuff parameters, and there's 4 of them. So I'm going to take this line all the way up to spec handle and copy it and paste it. And the next input, I'll go ahead and close the parentheses and add the semicolon. And the next input is the gameplay tag. That's going to be for those debuffs. So I'm going to go ahead and just get aura gameplay tags straight away. So const f aura gameplay tags. That'll be a const reference. I'm going to call it gameplay tags and use f aura gameplay tags get. So back down to our set by color magnitude, I'm going to use the debuff. And we need debuff chance, damage, duration, and frequency. So I'm going to use debuff chance. I'm going to get that first and set that equal to the value in our damage effect params for debuff chance. And we're going to have 3 more of these set by color magnitudes. The next one will be debuff. We can do debuff damage. And that's going to be the debuff damage from our damage effect params. We'll go ahead and do this again. The next one can be debuff duration, which will be set to, you guessed it, debuff duration. And the final one is the frequency, right? And that'll be set to debuff frequency. So now we've just assigned a whole bunch of set by color magnitudes. And apply damage effect can apply that damage gameplay effect. Now, this returns a context handle, so I'd like to return that effect context handle. This is just for convenience. I mean, we don't have to return this, but I just happen to choose to return this, and we'll see later if we need to use it. Now, our spec handle could be const here. Writer thinks I made a typo in effect context handle. I didn't, so now we have this function that can apply damage effects by receiving some params. Now this is great because the effect spec is now going to carry these set by color magnitudes along with it. And in the next video, we'll see how we can use this function. So give compiling a try. Let's see if we can catch any errors. Looks like I have one. uGameplay effect undeclared identifier. So I didn't forward declare uGameplay effect. I'm going to go ahead and do that. So I'm going to compile again. And that's going to do it. All right. Great job on the challenge, and I'll see you in the next video.